Good day. Today's session is going to be on the data link layer, chapter 6. So first thing we want to do is look at our LAN and our WAN areas. So we can see here in the yellow, it's a LAN area. And what defines a LAN is an interface off of a router. Now what defines a LAN is that it connects to another router. This router HQ is connected to a switch and two routers. So it has one LAN, and then it has WAN area between HQ and Wadsworth, and then a WAN area between HQ and Akron. And then you have a LAN area off of Akron branch and also a LAN area. So if we add another interface, gigabit, serial, doesn't matter, it'd be another LAN or a WAN, depending on what device it connects to. So let's look at the layer 3 and layer 2 addresses, do a little reconnaissance. So gigabit looks like it has a 172.16.1.1 with a /24. I'm sorry, /27. So if we want to convert that, we put down 8 ones, another 8 ones of 16, then we get to 24. So we actually have 27, 24 plus 3, 27. Then you add up your subnet mask, 128.64.32, it equals 224. So pay attention to where the 1 stops at. It stops at the 32. So we have .1 on this, and then if you follow the switches, .2, .3, .4. And so now let's go to the WAN area. It is a /30. So these both have /30, which is a 252. So to do a /30, so we should have 2 zeros and 6 ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there's your 230, or that's your /30, which is a 252, 255, 255, 252. And then you can see your layer 2 is a MAC address. So you see your layer 3 in your layer 2 and your subnet mask. All right. So what we're looking at now is layer 2 addresses, which is hexadecimal. And if we have a broadcast, like an ARP is asking, I have this IP address, but I need a MAC address. And then we're going to send out an FFFFF broadcast, which will go to all devices, which ones respond and which ones will ignore or drop the frame. Remember, data link is the frame. Okay, so the principal just called Miss Barb Brown down to the office. That's cool. So we would need to figure out, where does a MAC address have significance, and it's going to be for local only. So let's take a look at that. So what we're going to do is ping PC0 to PC1. So first thing I'm going to do is get to simulation mode. Expand my window so I can kind of see all the little details that I want to for my layers. And I'm going to slide this bar up just a little bit faster because ARP will time out. So we want to make sure we do as fast as we can. So let's go ahead and go to the PC. We're going to go to desktop, command prompt, and then the IP is 172.16.167. So ping 172.16.1.67. So first thing when it sends out, remember we're at layer 7, not in ARP. I'm sorry, not with a ping. It only goes to layer 3. So we see a source IP and a destination IP. So what happens with the ARP is you look at the, remember, layer 2 has MAC address first. Your source MAC destination is all Fs, so that's going to be a broadcast. Your source IP and your destination IP layer 3. So once it goes into the switch, we should expect a go in the switch and be broadcasted out all ports except the one that was received on. So it goes in. So at this point, all the end devices are ignoring or dropping that frame, and now the router is realizing that that IP address of .67, 172.16.1.67 is not in the same network. So it's got to be routed across the WAN. So let's see this request. We still see it's a broadcast, FFFF. So if we play it into the switch, we see that now the broadcast is eliminated. We have a source destination MAC and source destination IP. So now once we hit the ICMP, once again, we've removed the FFF with a unicast, layer 2. And then I'm gonna be a while. I'm on a line. So layer 2 address here in your physical. And then it should just, now, once again, it's gonna ARP between each one of these areas. So if we look at the router here, HQ and Akron, there's the broadcast. So what's gonna happen is the Akron branch will give the MAC address. So let's look at the next layer here. It got the MAC address of the next router, the layer 3 device. And so then we need to ARP again in the LAN, because now we're in area, LAN pink area here, and it's doing another broadcast. All right, then it kind of timed out right there. Okay, so we're gonna watch this again with the second PC here, PC10. So I'm gonna get out of simulation, reset. And I'm gonna leave this, I'm gonna keep it all the way sped up so we can get it done and we can go through the checklist. So I'm gonna go the shortcut for ping up here, ping packet, simple PDU, ping PC10, PC1. So we see the ARP broadcast. So we can anticipate the router HQ giving up the MAC address. So now we see that with the FFF has been removed. I'm just going to let it play out. Okay, right now we're back to another ARP because you've left your one LAN area. Now you're going across a WAN. You need the next MAC address. So Akron branch will give up on this next one. So if we look at Akron branch, you still see the FFF, and then over here, it replaces with the source destination of the router. And then we need one more ARP, which it comes down to the LAN area, and that timed out on us. So the conclusion is, if you're pinging within your LAN, you're going to get a response from an end device. If you have to leave your LAN, you need to get the closest router or gateway MAC address. And then at each WAN, you're going to do another ARP. And then if it's 3 WANs, you'll do 3 different ARPs at each WAN, and then you'll get back to your LAN and do another ARP. And then if we try to ping again, what'll happen is, since they've already recorded the MAC address, it doesn't need to ARP again because it has it recorded. And just to show you, we look in a switch here, show MAC address. Oh, there it is. Show MAC address table. So then if I look in my devices, I can see my actually MAC address table. So we can see that's what's recorded in gigabit 01, gigabit 21, and gigabit 11. And if we want to look at this in the PC, it would be ARP. So ARP-D in the PC shows an ARP table. So since we haven't done anything, so let's do a ping real quick. Remember, it's going to go through the ARP. Because we're leaving the LAN, we're going to the WAN to another LAN. We should get 2 timeouts, possibly 3. Why did that just fail? We'll have to see what's going on there. Well, let's see here. PC10 to PC1. Successful. So once we go through that again, sometimes packet tracer times out. So we can fast forward that. So now if we look inside the PC, we should see ARP table. So no ARP table here. So there's nothing in the PC. So that concludes how a layer 2 MAC address stays within its LAN local significance, and then the WAN actually is considered another local significance. So it'll flip-flop all the way across all layer 3 devices and back down to the LAN. That concludes our video today.